Good morning, everybody. So please give your attendance quickly, then give attention. So let us see our schedule. So according to our schedule, this week we are supposed to complete our searching and sorting algorithms. Okay, so actually we are one lecture behind. So I wish I could start this on Monday. Okay, I will try to finish searching algorithm today and then Friday sorting algorithms. If I cannot finish, then we have 4 more lectures after the spring break, after the Thanksgiving break. Maybe if needed, we will revisit sorting algorithm on after the break. But maybe we can finish. Let us try. So, but let us give attention so that we can go fast. Okay. So, by the way, there are some updates on our slide, especially if you downloaded module 7 two-dimensional array slide a few weeks earlier. So please delete your previous downloaded copy, get rid of your previous downloaded copy and download it again. Okay, so actually there was a mistake in one page, especially the two-dimensional array declaration in C++. On this slide there was a mistake. Previously, this is correct version in C++, but maybe previously this was like C# notation. This was previously maybe like it was like this C# notation, but this notation is for C#, not C++. Okay, C++ will have two different sets of angle brackets, one for rows and that for column. Okay, and I also uploaded my some programs. One of the programs that we are discussing about 2D array in C++. 2D array, how to find row and column if the size are different. For instance, for this two-dimensional array there are 3 rows and but 4 columns, right? So row count is 3 and column count is 4. So it is a little bit tricky way how to calculate the total array count in C++, how to calculate the row count. This is the way, and how to calculate how to compute column count. So people who are taking C++ lab, give attention over here. You can copy my code and you can remember it, or you can put it in your account. Okay, and this will work for any array, any two-dimensional array. Okay, today we want to discuss searching and sorting algorithms, module 8. There are several searching and sorting algorithms. Searching means finding. We want to find whether an element exists or does not exist in a list or in an array. Okay. And sorting means we want to display the elements of an array or a list in either in ascending or descending order. In ascending orders means we will put the elements, smaller element first, the next highest next, next highest next, next highest next, and all the highest element will go all the way end. So this is sorting and ascending order, and descending order is reverse. The highest element will come first and the lowest element will go all the way last. There are many algorithms for searching and sorting, and still computer scientists and programmers, they are continuing their research in order to develop new searching and sorting algorithms or make the existing algorithm better. Okay, still it is an ongoing process. So we will discuss two common searching algorithms over here, linear search and binary search, and we will discuss 2 or 3 common sorting algorithms: bubble sort, insertion sort, or selection sort. Okay, first of all, linear search. Linear search, in other words, we can call this is serial search. Okay, we want to search the array elements of a list element, starting from a point, maybe the starting point with index 0, first index, or index last index, and we will go one by one. That is called linear search. Okay, one after another. And binary search is applicable if our list is already sorted, then it is more efficient to use binary search. So let us see if we understand these searching algorithms. So if you give attention, and if you understand the concept, then program implementation is easy. Okay, give attention please, but in your whole life you will need to use this searching and sorting. Okay, so at least please spend for the next 30 minutes, give attention if you understand this, and then you should have a lifelong learning. Okay, but if you do not give attention, if you do not understand, then you will face issue whole life. So linear search, as we mentioned, that is searching one by one after another, maybe starting from the beginning of a list or from the ending of a list. So if there are n elements, number of n elements, maybe 100, for instance, element in a list or in an array, so linear search algorithm maybe can go in several ways. For instance, we have a bucket. An array is a bucket, right? We have a bucket, there are 100 numbers in it. 100 numbers in it, and there are 100 items. Each item has a number on it, a label. Then for instance, how can I search that whether a number, for instance 7, exists in my bucket or not? Okay, there are several ways that we can check one by one. We can pick an element, okay, and check whether it is 7. If it is yes, then I'm lucky, I got it, right? For the first try, I can get it. Okay, if it does not match, if I do not find my targeted value, right, what can I do? There are two options. I can put the first element back and I can get another one. Okay, that is another option. So in this option, if I put the same element back, then there is a chance that I can get the same element again, right? Then there is a chance. But there is a good way, if I put that first element that I picked first, keep aside, and I do not put that element in the same bucket again, then I will have one element less in the bucket, right? Then there is no chance that I will get the same element again, right? Okay. So the second process is the linear search algorithm, and it is more concise that if I start searching from anywhere, like randomly, right? But this is a process. If alternatively I can search serially, maybe starting from the first index or from the last index, and go wall by index. Okay. So however, if I'm lucky enough, I may find my target element at the first time, or I can get it all the way in very last. So if I am unlucky, then I may need 100 try. for 100 element, right? The last element is maybe my targeted element. So in that case, I may need to find 100 n times or 100 times. So for all algorithms, okay, if you have written an algorithm, if you write an algorithm, and then the next step you will be asked to check or verify how efficient your algorithm is, how good is your algorithm. How do we check whether my algorithm is good or bad? If it takes short time to execute, that is a better algorithm, and if it takes the shortest time, that is the best algorithm, right? Okay, so if you take your data structure or an algorithm course later, then you will learn how to find the efficiency or complexity of an algorithm. There are some notation, that big O notation, small O notation, omega notation. So big O notation is used for the worst case or maximum how many try you need. For linear search algorithm, you may need, for the worst case, you may need n try. This is why the complexity of big O of linear search algorithm is big O(n). That means if you have 1000 elements, then for the worst case you may need to 1000 try. You can get all the way last try, right? And you are lucky enough, then you can get first or the second try. Okay, the average time is n by 2, but the worst case or maximum visit you need in n. Okay, but complexity is called big O(n). Okay. So linear search algorithm is applicable for a small data set. We usually use linear search algorithm if we have a small data set, then it is fine. Okay. But if we saw the implementation of linear search algorithm is pretty straightforward. If we pass this, for instance, if we want to implement a method for linear search algorithm, for instance, my method is linear search, and usually if we pass a list or array as a parameter, and this is my target value that I want to search whether my targeted value is available in the list G here or not. So that the way is that we will start searching the list elements starting from the 0th index or first element, and we will go all the way end, and we will check one by one. If my element equal to my targeted value, then we will return something, maybe return a true value, or we will say item found, and or something, we will return some value, and if it does not available, then we will return false. That means the item does not available. Okay, this is the pseudocode format, but maybe this is better understandable if we see program code actually. So this is a linear search algorithm. This is my method. I am passing an array to it. Okay, and this is the target value. I want to check whether this target value is available in this list or not. This is my problem. How we want to solve this problem? We will start from the beginning with 0th index of my array, and we will go, we know that in Java we have length attribute. We can use I less than array dot length, so we will go to all the way last element, and we can check one by one. We will check if array I, that means we will guess the ith element, and we'll check whether my targeted value is found or match. Then if it match, then we will say return true. Return true, we are returning true because we give return type of this method as boolean. And if does not match, then return is false by default. Okay, we can give any return type. If I say string return type, then I can say, okay, if found, then I can say found or something like if return or return. If I have string return type, so I can say element found or something like this. we can say string, and we can say not found over here.
Question.
Yes.
How do you know what target value is? Do we have to initialize it somewhere?
No, target value we will give. For instance, I have list. You will be given a target value for 7, for instance.
Okay.
Target value is your desired value that you want to check whether it is not available. Okay. Yes, it should be a known value. Target value should be known value. Yes.
Why would it not return true and then false?
So in this method, I can implement any way. I can give any return type, value return type. So if I give my return type boolean, then it returns either true or false.
Would it return true and then return false?
Sorry, here return false is that if it does not match, if condition is fails. By default, we will think that condition fails. If condition pass, condition meet, then we will say true. Otherwise, we will say that condition is false. In our daily life, we assume something false. Okay, when a student get admission at a university, right? Student is by default said he is not graduated. And after he graduates, he completes all of the requirements, he said he is graduated, right? His graduation is fulfilled. So in your real life, many things we say by default false, or by default, there are something we may say by default true. Whatever you say, you can put alternatively. I will discuss with a live program soon, okay? So then you will understand better. So this is Java implementation, and then people who are taking C# lab, give attention here, please. So in C#, almost everything is same, but here the length L is in uppercase, right? For length attribute, L is in uppercase, and everything is same. You can do. But people who are taking C++ lab, okay, give attention here. C++ is a little bit tricky here. So we know that in C++, if we pass an array as an argument to a method, okay, that is considered true, related to pointer. Okay, that is. So in one of our previous lectures, we showed that we need to use the size, another variable size over here for C++. And here, since C++ does not have the length attribute, okay, so we will put integer size over here, another extra argument, and we will say I less than size. And in our caller method or host method, we will compute the size. Just I showed at the beginning of this lecture how to calculate size of an array, even row or column, or size of an array. We know that, right? So we can use this formula, this technique in our main method to compute the array count or array size. Okay, otherwise it is same. Okay. So this is linear search, or we can say another ways we can say it serial search. Okay, the elements are searched one by one until we find our element, or if we want to ask say how many times our target value exists in a list, then we need to go all the way in, starting from the beginning, right? So based on our problem in hand, we will implement our operation. Okay, so since time is short, I have to finish these two algorithms in one lecture. Usually I would spend at least 2 lectures. Okay, so what I did, I coded my programs on my Replit account in all 3 languages. So if you go to my Replit account, so you see that I have added linear search example 1 with Java, same problem with C#, and same problem with C++. So according to your favorite programming language, please you can go to my account and open your program. Let me open it and show you the 3 programs. The first one is linear search example 1 with C#. Okay, I got it, C#. Okay, so C# we have bool. The keyword is bool, and C++ the keyword is bool. Well, Java the keyword is boolean, right? You remember that, you know that. And we have the length attribute over here. So this is my find a number. For instance, I have my array. So this is the method, our algorithm. This is the implementation of my algorithm, that I want to check whether, for instance, this is my array. For instance, this is my array, my data is my array. Whether my array contains 7, and if it contains 7, how many times it contains. Okay, if I run this program, you see that how many times I do have 7 over here? 2 times, right? So it's showing that my number 7 is found 2 times. Okay, if it does not exist, then it would, if for instance, if I check 77, the 77 does not exist here, right? So if I run this program, then it will show 77, the number 77 is not found. Okay, so this is my problem that in hand we want to do. So I want to search whether a number exists in my list, and if it exists, how many times it exists. So it has one step ahead than our traditional searching algorithm. So how do we can implement this? We just need a boolean variable flag. Initially we need to make it false. Okay, then we also need another count variable. Initially that is 0. We will count this, how many times an item exists. So starting from the beginning with 0 index, and we will go all the way to the last index. Since we have less than sign, right, we will go last index over here. We will say if this is my array I equal to my target. So here you see that how do we define a method? We define a method with just common variable name. My common variable name is target, and when I call this method, I will provide a value for target. Like you see that when I call this method, I will call this method like this. I will pass an array, our name over here, array name, and I will put any value that I want to search this value within this array. So you see that our implementation, this implementation of method implementation is in general implementation. It does not say any specific array. It does not have any specific array. Okay. We will provide the specific array name when we call this method, and we will provide the specific targeted value when we call this method. But here we just using we just using the array name over here. Okay, and we know that C# has the length attribute, right? So we are finding the length over here. So if we find my array ith element equal to my targeted value, we are making our flag true. Okay, and we are counting, increasing our count. That means we got 1 time. If I find it again, then we will get another increment by another 1. So here in this program, I can say return type void, or I could say return type any true boolean value. So however you implement in your algorithm, you can go. So return type you can implement as you want. So in our slide, we did have return type something, right? Return type true or false. Okay, so you can implement as your own way. So this is the implementation in C#. Okay, and I also added two other methods, one to find max number, another to find mean number. So in this array, so I can call find max number and can call find mean number, and then it is showing max number, but this array is 20 and mean number is -3. Okay, so if you understand the basic concept, then you can copy this program. Okay, run this program from my account, or you can copy this program and put it in your account and run it and change it, especially change your array list over here, array here, array items here, or your targeted value here, and check whether it works for any array and any targeted value. So this is the C# implementation, and let me see if I have Java implementation for this one. Okay, linear search example in Java. Okay, the program in Java and C# are exactly same, but we have only one difference. In Java we have Boolean keyword, right? In C# we have bool, and then in Java we have length L is in lowercase attribute, and almost everything is same. Okay. So now let us see C++. Okay. Okay, but the C++ implementation is a little bit different than Java and C# implementation. So people who are taking C++ lab, keep attention here, please. So as we know that in C++, if we pass an array as an argument of a function, we also need to use another variable to get its size, because the array is passed as a pointer in C++ only. Java does not have pointer. So in Java and C#, since we had our size attribute, length attribute, so then it was easy for Java and C#. But since C++ does not have the size attribute yet, or length attribute yet, okay, so we need to provide another argument that is for size, and just we will use size over here, nothing else. But we are not going to compute size here. We don't need to compute size over here. So we need to compute size in my main method, where I'm going to call this method. So this is my main method. I'm going to call by find a number over here. So then I need to provide size over here, but I will compute the size. We know that how to compute a size in C++, right? So this is the formula. We can find the size. Okay. And so this is why for C++, in order to call this method, we need to, in order to implement this, we need one extra argument to pass for size, and when we call this variable, we need to put that size over here, and also we need to compute size, and this is my data and this is my targeted value. Okay, so this part is extra in C++. Yes.
Why can't you just find the size inside of the method by using the
Here in this method?
Yeah, why can't you just find
I tried. Maybe there is a way I tried. I could not. It showed error. In one of our lectures, previous lecture, we found that we need to compute. We cannot compute here. Okay. In C++. Maybe there is a way, but that way is not easy. C++ has pointer, so we did not discuss pointer here. That is out of our content. Are you taking C++ lab? No. Then your life is easy. I'm sorry. people who are taking C++, don't worry, okay? But okay, one of the thing that, okay, so this is the thing in C++. Even if we call the find max number or min number, okay, we need to pass another size. So that the rule is that whenever you pass an array to a method in C++, we need to also use another size variable, to indicate size, because the reason is that this array is passed as a pointer array, okay? Okay, another thing is that, object Java and C#, so the way we wrote this program, Java and C#, these are completely object-oriented programming, program. So at this point, we understand what is an object-oriented program, right? What is the trick? What is the way to understand that know that this is an object-oriented program? Can anyone please tell me? So that trick I told you, how do I know that this is a function? If we see a pair of parentheses, right? Then this is a function, right? How do I know that this is an object? If we say a pair of square bracket, then this is an array, right? Okay, how do I know that this is an object-oriented programming? Okay, you see that, you see here, the symbol is here. If a program starts with a class, then that is an object-oriented program, okay? So this program, it starts with a class, right? So all cores, you see that all cores are enclosed within this class. Nothing is outside the class. This is an object-oriented programming. In an object-oriented program, you will have all of your cores, everything bounded or enclosed within a class. So as long as you have a method within a class, no matter if that method is private or public or protected, every member will have access to this method. So for instance, this method is private and static method, right? This is defined within class, and it can be called within main method. Since it is a static method, so we do not need to call this method by its class name. We can call, but since it is within class, these are the siblings. Okay, the main method and find a number method, these are siblings, all in same family, okay? So then we do not need to use main dot. If it is outside a class, then we needed to use this. Okay, it's okay, but if you can use it. It will work even if you use main dot, because we know that how a static method is called. A static method is called by its class name, right? Class name dot, but non-static method are called by object, right? So this method is static method I defined, so I don't need to create an object. I can do this, but since this is within class, the same family, even we do not need to use main dot, so that we can call directly. Okay, so as long as this method is within my class, even no matter, for instance, you see that I call my find max number, but it is not defined here, right? Find max number. Do I see my find max number? It is not here, but it is below the main method, but it is working since it is within class. As long as these methods are within class, it will be working. Okay, but in Java, in C++, in C++, so if I have a method, for instance, if I want to use a method, any method, find a number, so I must define or declare the method above it, before this statement. So C++ people give an answer. So this is not an object-oriented program. I do not have any class here, right? So people who are taking C++, give attention here, please. See that the reason this is not an object-oriented program, because I do not have enclosed everything within a class. So here I have my find a number with this method, and I am calling this find a number within main method. Is okay. So my main method I'm calling find a number. It is working. But I am also using find max number and find min number, but these are not defined before my main method. So then at least if I declare this, if I have this code, better if I have this code before I call them, before I use them here, then it will work. But in that there is a problem, is that these are your subordinate or subsidiary methods. Okay, so it may happen that you will spend a lot of lines, okay, in order to implement your subsidiary method, but your main method is going all the way end. So some people, new programmers, may be misled. What is my main method? Which one is the starting point of my program? Okay, they may be confused with this. Okay, so this program it works. You see that this program works. Let me see. So by giving this way is not a good way. So the good way is that I will have my host at the beginning of my party, right? So if you go to a party but you do not find the host, then what will happen? Okay, so then I will have my host, my main method here, and I will have all of my guests below my main method that I'll be calling. But this time it will not call, it will not work. You see that if I run this program, it will show me an error. The errors are here that the main method does not know where is the find a number method. It says find a number method is undefined. Find max number is undefined. Find min number is undefined. That means we defined it. Since this is not an object-oriented programming, there is now no class, right? But we defined it afterward, but it will not work. So what do we need to do? We need to declare at least the signature of this method. Like this is called the signature line. Okay, at least we need to declare this, but by doing this we are telling our compiler that, oh, I will be using a method named find a number with this structure, with this list. Okay, so here similarly if I add this after here anywhere at the beginning, then it will work. And say if I add another one, maybe for the find min number, if I declare the signature, this is called signature line, okay, then it will work. Then no matter where I declare, the outside, after or before, it will work. Since it is not an object-oriented program, okay, there is no class, okay, but for Java and C# we don't have this headache. Only C++ people. Okay, so I have my code in my Replit account. So get this code and then to practice. Okay. So anybody has any question about the linear search algorithm? So this program is doing what is same thing. It is counting how many times a number exists. Anyone has any question? So linear search algorithm is straightforward. Okay, and it is most widely used. You will use also in your life, and then it is efficient for a small data set. If your array is any kind of array is small, okay, but if your array is huge, very large, there are millions of record, millions of data cells in a table, okay, or in an array, then this algorithm is not efficient, because we saw that my targeted value may be all the way last element, right? It takes big O n search time, right? So there are other algorithms like that we want to discuss right now. Binary search algorithm. Binary means two, right? Bi means two. Another efficient algorithm is called binary search algorithm. Okay, that might be efficient. That take very actually small amount of time or searching. So the time of complexity is big O log n, actually with base 2. Okay, that for instance, if I have 1028 elements, and if I want to search an element from an array that has 1028 elements, for linear search I need maximum 1028 search, right, iteration, right? But that can be done, that can be found in a binary search algorithm by 10 iteration, way less than, right? But there is one requirement in order to implement binary search algorithm, is that the array must be sorted. The element must be sorted either in ascending order or descending order, pre-sorted. Or if it is not sorted, you need to make it as sorted array. You need to sort the array first, then you can implement binary search algorithm. If it is not sorted, or if you do not want to sort it, if you cannot sort it, then you cannot implement binary search algorithm. Okay. So here I also, in my Replit account, I also add programs for binary search algorithm in C++, C#, and Java. My algorithms works. I like you to go to my code and then try, okay, and then understand. How many minutes I do have? 5. Okay. So let me give a quick. Okay. Okay, I got C++ program. Okay, I got C++ program. So this is why you see that my array elements are already sorted. If it is not sorted, then I cannot implement binary search algorithm. Okay, so we have to make an agreement that our list is sorted. Array is sorted. So is sorted, right? So then I can find that. For instance, what is the number I'm searching for? Number 5. So number 5 is the with index 3rd element, right? With index 2. Okay.
So, let's say that there's a random set of numbers in this array.
Yeah, any set of number, but the condition is that must be sorted.
Right, so we can initiate a array sort first.
Yeah, that is the thing, that if your array is not sorted, you need to sort it fast. But sorting takes more time. Sorting is more complex than searching. In our next lecture, we will discuss sorting elements. Okay, you will see that sorting is the more complicated than searching. So binary search algorithm is applicable and easier to if it is sorted. Already the array is sorted. Okay. So then the concept of binary search algorithm is that. Okay. Let me see. We know that, for instance, if we have 32 elements in an array, okay, so we know that our elements are already sorted, right? So if we have an array with 32 elements, right, we can compute the first index and last index easily, right, by using length method. We can compute the first index with index 0 and last index with index length minus 1, okay, and then we can compute the middle index, right? How can we compute the middle index? First index plus last index divided by 2, the middle index, okay. So by getting 3 indices, first index, middle index and last index, right, we can compute the values on these indices, right? So we can easily compute the values that will be in the middle point, middle index, right? So for instance, our array is already sorted. We can easily find the element what is in the middle. So now, for instance, we need to check a number, for instance 10. We know that if we know that the first element has, like, for instance 1 or 0, and the last element is maybe 30, 40 or 50, anything, okay. So then we get the middle value. If we find the middle value easily, and if we will compare the middle value with my target value, okay, if my middle value is greater than my target value, then what will think? If my target value is less than my middle value, then we will know that my element exists in the first half, right? So then we do not need to go to the second half. We can discard the second half right away, right? So then our array size becomes half in one try, right? So then again we will make the array size again 2 halves, and now we will check. We will at this point, if our element is in the first half, we will update the last index. Okay, last index will be middle index, because we do not need to go the right side at this point. We will update the right index, and then we will find again another middle index, and we will compare that middle index number at that middle index with my targeted value. By this way, after every split, our array is going to be smaller and smaller and smaller. At the finally, we will get only one element, right? We will find only one element. So 2 elements, one side one element, another one side. So then it is easy to get that element, compare that element. Okay. So the implementation of binary search algorithm is a little bit trickier than the implementation of linear search algorithm. So here, that every time we will compute the middle index, and we will find the element at our middle index position, and we will compare whether my middle element on the middle index is equal to my targeted value. If it is, then we will return, we found it, right? But if it is not, then there are 2 possible cases. One may be targeted value may be left side, or targeted value may be right side, right? So if targeted value is less than middle value, then we will update the right index, highest index will be mid, okay. And otherwise, that means if my target value is greater than middle value, that means our element reside on the right side, then we will update the low index will mid. So that means we will discard the lower part, and we will continue this until we compare and finish our array. Okay, so the Java implementation of linear search algorithm is here, and the C# implementation is here, almost same, and C++ implementation is almost same, but we have to add only an extra variable for length over here for C# implementation. And once you understand this implementation, please spend some time to understand this implementation. Then I have program written in all 3 languages. Okay, binary search algorithm in C++. If you go to my Replit account, you see that binary search algorithm written in C++, written in C# and Java. So according to your favorite programming language, go to my program and play with it. Okay, make some changes and try to understand. Anyone has any question? Thank you so much. And after our Thanksgiving break, we will discuss sorting algorithms. Oh, sorry. In our next lecture, right? Friday lecture, we have one more lecture. Friday, we will discuss sorting algorithms. Okay. Anyone has any questions so far? Okay. Thank you so much. And please do some practice. Okay. Thank you so much. And you have a good day.